Okay, today we will just go over a random topic of geometry. I just chose it to be similarity, so it's an easy topic. Before we start, I would like to write a proportion question as for a warm-up. So I would like you guys to solve this equation. Okay, so let me just write it right here. Can you guys please solve for x? If the equation is given as x minus 9 over 15 is equal to 2x minus 9 over 10. While we're waiting. And then you can put your answers on the chat. And everyone can see your answer. Selena was the first one to get the answer correctly. Awesome, Selena. Alvin is also getting it correctly. Perfect. Good job, Alvin. Sure, check your work, please. Not the correct answer. Ellen, that's the correct answer. Okay, Ryan, I'm gonna go over this one briefly. So if you have such a proportion, like we need to solve proportions, Jayron, that's correct. Crystal, awesome. Okay, to solve such a proportion, because we will be dealing with proportions here, and you need to know that much of algebra 1 knowledge to get that. Sarah, good job, correct. Let me just go over this briefly. So I need to cross multiply these, and I'll need to solve that equation. So I'll multiply 10 by x minus 9, 10 times x minus 9. Since x minus 9 is a binomial, you got to put that in parentheses, is equal to, then you will multiply 15 by 2x minus 9 times 2x minus 9. And if you are multiplied by any binomial by a number, you need to put the binomial inside the parentheses so you can distribute that. Good job, James and Alicia, you just got the correct answer as well. Okay, let me just continue here. I'll distribute to 10. 10 times x is 10x, and then I'll distribute the 10 to 9 as well, 90. Is equal to 15 times 2x, 30x, and 15 times negative 9 is, oh, that's a big number, right? Negative 90 and negative 45, negative 135, I think. You can unmute yourself to join the class, and then I want some videos on. Why is everybody why did you just guys turn off your cameras? Okay, Caitlin, how are you? And yeah. Everybody's like, I don't see anyone. That feels weird, you know? Okay, did I do everything correctly so far? Now that I have x on both sides, I need to get rid of one of the x terms. And I get rid of the smaller x term usually. Since 10x is the smaller one, I get rid of this one. So I need to get rid of this. So I'll take away 10x from both sides. And then whatever you do, you got to do the same thing on both sides of the equation. So I have negative 90 left on this side. And here 20x. And then negative 135. Then I will look at the variable side, and I'm trying to isolate this variable here. I want to leave this alone. Okay, in order to do that, so I need to get rid of any other terms. I have a minus 135, so I got to do plus 135. If I add 135, this cancels out. I just have 20x. It's going to be equal to 135 minus 90 is going to give me 45. And divide both sides by 20. So that will give you the answer. Canceling this out, x is going to be 45 over 20 is 9 over 4. You can leave your answer this way, or you can actually just write the decimal equivalent. Both of them are correct. Patrick, good job. Yep. All right, so do you want one more like this? See, I just completely skipped. There was a portion where you needed to first exercise on the proportions. I completely skipped that part, and then because that's kind of like algebra 1 to me. So let me just give you one more Some people just ask one more, just one more. Okay. And I want a nice answer, not a like decimal answer this time. So I'll just give you a nice integer answer for this one. X minus 16 over x plus 6 is equal to 3 over 5. Let's solve for x as well. Selena is again the winner, like she's the queen of equations. Got it correctly first. Jayron is really fast as well. Alvin, Ellen, Lily, Suhurit, and Jason, they all got it correctly. Good job. Awesome, Yifan, good job. Ellen, check your work. Maybe you made a like little mistake there. Make sure that you just multiply this. Solving, Ryan, you gotta work on solving proportions. If you are thinking that you don't know how to do this, solving proportions. So Google this like one more time, like maybe just watch some videos on YouTube on how to do it. I'll just solve it as well. Yes, Kavish, that's correct. Also, Josh, Patrick got the correct answer. Ellen got the correct answer. And James, check your work, please. Now I will just go over this problem. Yeah, in Algebra 1, you should have seen that one when you're like working on solving equations. If you didn't take Algebra 1, I suggest you first take the Algebra 1 class. Caitlin, good job. Krish, you are very, okay, you are now correct. I was like, how can you be like one off, you know? Okay, so let's cross multiply this. I will multiply 5 by the quantity x minus 16. And here, a common mistake is like when you're distributing, if you multiply just x by 5, but not 16, that's the common mistake here. And then on the other side, I'll have 3 times x plus 6. And then these two must be equal to each other. So let's distribute 5 over x minus 16. 5 times x is 5x. And then 5 times negative 16 is negative 80. 3 times x is 3x. 3 times positive 6 is positive 18. Then since I have equation, and since I have x on both sides, I need to get rid of the smaller one. I want to get rid of the smaller x term, that's the 3x. Because I don't want like x to contain a like negative x, coefficient. That's why I always like get rid of the smaller one. Minus the 3x from both sides. 18 on this side, and then 2x minus 80 on this side. Now that I want to leave x alone on one side of the equation, then I need to get rid of any extra term. And the extra term that I have here is the negative 80. So this negative 80 must go away. I need to have only the x term here. So in order for that to go away, I got to undo minus 80. Undoing that is like plus 80. And because there's an equation, it's like a balanced scale. You got to have the same thing on both sides. If you do one thing on one side, you got to do the exact same thing on the other side as well. So that has to be a plus 80 as well. So cancels out, 2x is equal to 98. And last step is undoing that times 2 for x. And undoing that is like dividing by 2. And then that will lead me to the correct answer to be a 49. All right, I got lots of correct answers on this one. So you guys know your Algebra 1, I guess. And if you don't know how to solve proportions, like still you can work on solving equations on in the Algebra 1 class and solving proportions to be more specific. Okay, so similar polygons. You have seen this like topic many times, maybe in middle school math as well. So, but we are gonna just see it a little bit more deeper. Similar polygons have the same what? What do you think do they have? You can unmute yourself.
Angles.
Same angles, that is correct. Good job, same angles. That's not the exact word I'm gonna use here, but that's absolutely correct, Sword. They have the same angles.
Shape.
Same shape as well, see? Same shape. When I say same shape, I really mean like they must have the same angles, everything, all angles must be the same. But different size size, not size or side length, right? Different size. So the side lengths are going to be like proportional with each other. Polygons are similar. If they have the same shape, that means that corresponding angles must be equal. Let me just write corresponding angles are equivalent. And when I say equivalent, like when in geometry, for numbers, I'm going to use the word equivalent. But for shapes, I'm not going to use the word equivalent. What do I use instead?
Congruent.
Congruent. That is correct. Congruent. Congruent means like equal shapes, if equal measures of shapes. Okay, corresponding side lengths are proportional. Corresponding sides are proportional. Well, Ryan, that is the first step. You got to learn Algebra 1 first before the geometry, I think. That would be a good idea. Yep, proportional sides. Good job, Jaren. Thank you so much. The ratio of the corresponding sides is called
Scale factor.
What is it?
Scale factor.
Scale factor. That's correct. Scale factor. Some people know their similarity. Good job. If polygons are similar, then their perimeters are also proportional.
Areas, right? Or no?
Perimeter.
There's
Side length, corresponding side lengths are proportional. Perimeters, any length that you can think of the shape will be proportional. Like their altitudes will be proportional as well. And perimeter is a length too, so perimeters are going to be proportional as well. What's the scale factor of, like, let's look at these two triangles here, A, B, C, and D, E, F. They are given to us as similar. How do I know that they are similar actually? Because I know that all angles are same. See, this angle and that angle are same. This angle and this angle is same. B is
3/2.
And F and C are congruent. So what is the scale factor of A, B, C to D, E, F? And as a matter of fact, the order of this matters too. Like, do I make the ratio of small to big? Then you gotta get a ratio that is less than 1, as a matter of fact. Because it says A, B, C to D, E, F. A smaller triangle to a larger one. So what are two corresponding sides? Yes, Ellen, that's correct. Yeah, let's say AB. AB corresponds to which side length? DE, right? How do I know that they are corresponding? Because they are both opposite to the same triple marked angle. Opposite to the same angles, you will have corresponding sides. Also, you can look at the sizes as well. The shortest side would be corresponding to the shortest side. Okay, so, and then the ratio of these two will give you the scale factor. So AB over DE, which is 8/12, is going to be my scale factor here, 2/3. What is the scale factor of DEF to ABC? What is it this time? So some people already wrote the answer.
3/2.
Caitlin and Jaren. It's going to be 3/2. So the order matters. Like if you are given two shapes, if they ask you the scale factor from one triangle to another one, so you got to be very careful about the order, because you might get the reciprocal of the correct answer. So you need to be very careful. What is the ratio of the perimeter of DEF to ABC? And because perimeters are side length, are lengths, right? They're gonna have the exact same scale factor, even without calculating anything, because this is 3/2. That has to be also 3/2. Any side length or perimeters will have the exact same ratio. All right, let's go on. A validity statement must match corresponding angles and sides. Write similarity statement for triangles above. Okay, so how am I going to write this triangle is similar to the other one? So I'm going to be using this similar to symbol. So that means similar to, a squiggly sign. And now you got to go with like the corresponding angles. Now I have a single marked angle A, and the single marked angle here is D. So if I just name the first triangle however I like, I want to just name it as ABC, the triangle ABC is similar to triangle. Now you gotta actually follow the exact same angles here. A corresponds to D, so I know that I need to just put D first. Okay. If I put the name of DEF in any order, that wouldn't work. you gotta write that in an exact same angles. I mean, if E is the smallest angle here and corresponds to A, you gotta put E first. Okay, so the second triangle's name, you cannot put it any way that you like. So you need to actually use the corresponding angles. And then B corresponds to E. So then I'm just gonna write E here. And then C corresponds to, see that have that triple mark here. And then this one is a triple mark too. So same angles must match the order. Does that make sense? Like same angles must be with the same order. Because like when I look at this statement now, if you can correctly write this statement, you can actually tell me the corresponding angles. And I know that angle A is congruent to angle D because they are corresponding. And I also know that the angle B corresponds to angle E are congruent to each other.
Congruent or?
They are congruent and they are corresponding. Okay, because the corresponding angles are congruent. I mean, if they tell me what angle is exactly the same measure in the other triangle, I know that F is, because they are corresponding angles, so they are congruent to each other. And I can also write down what side lengths are proportional, right? So I can also write AB, the first two letters, AB, the side AB, will be corresponding to the first two letters, DE. Without looking at the triangles, I can actually write down the ratio of the side lengths here. And then if I go with like the last two letters, BC, I know that that side is going to be corresponding to, so these are not going to be congruent. These are just proportional to EF. And then the ratio of AC to DF will be proportional as well. And then all of these proportions are equal to each other. So they are all proportional. So if you can write your similarity statement correctly, then you don't need to look at the shape anymore to write down your equations. Okay, let's do one more together. And I know like this is kind of like intimidating, right? And you'll like to like write down equations, solve for them and stuff. But once you get to geometry somehow, like in the curriculum, you need to deal with proofs, and you need to justify your answer. And if you are getting a new theorem, you gotta prove it first to use it. So they kind of like made the geometry curriculum a little bit more boring as compared to like algebra 1, algebra 2, pre-cal and stuff. So here I need to teach you a little bit like that. I'll just try to refrain from the proofs and stuff as much as I can, but you gotta learn that it's in the curriculum. So I will just like touch on that briefly for each topic. Okay, let's list all congruent angles and write the proportion that relates to corresponding sides. Now a similarity is given to me, as you see. So now you don't even like need to look at the shape. You can actually just look at this statement and write down all the congruent angles. What angles are congruent to each other? Tell me. Angle L is angle L is
K and M, J and P, K and M, and
okay,
L and
L and N, right? Okay,
L and
angle K is congruent to angle.
angle congruent to angle M.
M, right? And then angle J is congruent to, and then congruent to has an equal to sign underneath that squiggly sign, so that means congruent to angle P. Awesome. Who said that?
Caitlin.
And then Jaren just gave me all of them. Okay, thank you, Jaren. And if you follow the letters as I said, then you can write down the proportion of the side lengths. I will just write underneath JK. What am I gonna have?
PM.
PM. Awesome. Is equal to KL over
MN.
MN. And then I know that JL has to be corresponding to MPM, so PM as a matter of fact. Is this easy? Okay, now we can move on to the next one, I think. So we can do like one here. It doesn't necessarily be a triangle. It can be a quadrilateral. It's gonna be exact same thing. So you're gonna have one more equation, one more proportion there. So by looking at these two, I want you guys try and write your own corresponding angles and proportion of the corresponding side lengths. Like J over Q is equal to what? So write all of them, please. Oh, Caitlin Collins can write on the screen. Okay, awesome. Can you write on the screen?
Yes.
Okay, who can annotate? You can annotate, I guess.
I can. I just
Well,
was what it was because I don't usually.
No, just you click on annotate. Click on annotate, and
Yeah.
you can write with your mouse. See, like I'm just gonna write the first part for you, okay? So angle J is congruent to, and I'm using annotations as well, like you. Normally I don't use annotations. Awesome. Angle K, angle L, angle M, and then I want you guys to fill the rest. Suhurit is having hard time writing with his mouse, right? Yep. See, I have a pen, that's why like my job is easier to write. And also I want you guys to write the side length ratio. I'll write the top versions for you. JK, KL, okay, and then let's say LM, you'll write the denominators here, is equal to JM over what? Okay.
It's really hard to do it.
Yeah, with a mouse, right?
Yeah.
And how many of you are having the school online, like right now? Just raise your hand from the reactions or something, or you can do clap hands, whatever there is there.
I'm
Just
home.
from the reactions, just do a hand gesture if you are doing it online at the moment.
I'm doing homeschool, so not really.
Yeah, only like 1, 2, 3, 4, 5, 6, 7. Okay, not that many. 7, 8. Maybe half of you are doing it online at the moment. Is there anyone who does it face to face? Who goes to school at the moment? Raise your hand. Really? Caitlin, are you going to school?
I go to school at my house because my mom's my teacher and we do it face to face.
No, not really. I want, who is going physically to school at the moment? I mean, who started already? Fiona started it. Kushi started it. Okay, well, that's interesting. How is school, guys? Yeah, not virtual. I'm talking about face to face. Who now goes to school? Like who started school face to face? Only 2 people, I think. Yeah, some people hate online school. Okay. Yeah, I don't like it that much either. It's hard for the teachers too. They need to like provide you all the materials online, and then they need to like teach. And if there is a kid at home, like that's really hard to teach. All right, so you guys write that. You can read these ones, right? I have a hard time reading them. Okay, I'm just gonna erase everything. Clear all drawings. Okay, there you go. This is better. I'll just move on. You guys got this one. All right, finding side lengths, missing side lengths here. When so these ones are very easy, I think. So let's do 7. If PQRS quadrilateral is similar to WXYZ, find the value of X. Are you guys done already? Put your answers on the chat. They just made this too easy. This time you're gonna like write down the proportion of the side lengths that are given to you. And write down the exact values. And then the first answer I got is from Avery. I don't know if the name is correct. Crystal, your answer is correct. Victoria, Suhurit, good job. Jairon, Trisha, Kushi got the correct answer as well. Good job, guys. All right, so X is the smaller of the sides, right? RS, and I need to actually make sure that I'm actually writing this correctly. RS is X, right? And then what does that correspond to RS? Last 2 letters, YZ. is equal to PS is the next time, like that's the one that's given to me, right? So I got to deal with PS here. And then PS is the first and last letter here. First and last letter will be like WZ. So do I need to do this if it is so obvious? Not necessarily. You can write x over 32 is equal to 75 over 40. But if you don't see that, you can actually just, or if you want to make sure that your answer is absolutely correct. Okay, so RS is actually given as x, and then YZ is given to me as 32, and then PS is 75 over WZ is 40. Then the rest is like cross multiplication, but before I cross multiply, I would like to, yes, Caitlin, that's the correct answer. Divide both numerator and denominator by, I want to just like reduce and simplify this one. I can divide them by 5, right? So it's going to be 15 over 8. All right, then I will cross multiply like I did earlier, but it's an easier one, of course. So 8 times x is 8x is equal to 15 times 32. And then I divide both sides by 8. So x is going to be equal to 15 times 4, which is 60. Any questions on this one? Would you like to solve one more like this, or was it too easy and skip it?
Skip it.
Skip it. Okay. Awesome. All right, but then we have some things like this one. See, I want to do like number 9. That looks a little bit more complicated, and it wants you to find both x and y here. Would you like to try to like write down the proportions here? You gotta be like writing all 3 sides, but you gotta solve them 2 by 2 here. So let's see how fast you'll get the answer on this one. Jason, I was gonna skip it. Then I have seen a harder question. Then and it's not that obvious on this one. So let's do this one as a practice as well. You have 2 answers though. Yep. You can actually just give me x plus y here. Can you guys like, if you don't want to type 2 things, add x and y and then give me just 1 answer. That is correct, Suhurit. Good job. Crystal, perfect. So I got 2 correct answers so far. Come on, guys. That is correct, Ellen. Awesome. Yep. Thank you so much. So I got 3 answers already. So let's solve them. James, one of them is correct. I think you made a mistake on the other one. Okay, so tell me what side corresponds to 45. This time I'm not gonna go with letters. So you can go with letters. JL corresponds to ML, which is this one, right? So NL. So these 2 sides are corresponding here. They're the longest sides in these triangles. So I can write 45 over Y. Then I'm gonna pick 2 sides that has the measures already. So 40 corresponds to 16, right? And then JK, you can check it, and M. So they are like corresponding to each other. So that's gonna be 40 over 16. One thing you need to be careful is if you go from big triangle to small one, you always go like big to small when you're writing the ratios. Okay, then you simplify this one. It's 8 over 2. No, divided by 8, so you'll get 5 over 2 as a matter of fact. 5 over 2. And then you can use this ratio. 5 to 2 is this scale factor here. So multiplied by 2 and divided by 5. So y is equal to 45 times 2 divided by 5. It's going to be like 9 times 2, 18. Then I'm going to like write down the other ratio here. So x to 14. And then I'll make that equal to also the same scale factor. It's 40 to 16, which is 5 over 2. Let me just simplify that and write 5 over 2. Cross multiply this. So 2x is equal to 70, x is equal to 35. Awesome. Good job, Jaron, Yifan, and James. Moving on. I don't see any like fancy questions. Maybe 12, maybe. If triangle BNV is similar to triangle BRG, and BR is given as, so this length is given to you as 4x plus 7, and BG is given to you as 18. Oh, not drawn to scale, I guess. Because like VG doesn't look like a 10, right? But it is a 10. Find
I
the
think
value.
it means RJ.
Which one? It means BG, right? I don't think do you think they meant RG or something? Yeah, so they said BG, so that's 18. Because this side like looks longer to me than this VG. So this is given to you as another 10, I guess. But use the given measurements and try to solve for X here. It's not necessarily to be drawn to scale. I already got a correct answer. Victor got the correct answer first. Crystal, check your work. Suhurit, your answer is correct as well. Crystal, check your work again. It wants you to solve for X, not the entire length or anything. See, I think, Crystal, you are finding the length of BR or something. It just wants you to solve for X, that's all. Ellen, the answer is an integer. James, that is the correct answer. Good job, you found. Awesome. Where is X? X is here, like BR, the length of BR is given to you as 4x plus 7. So this entire length is like 4x plus 7, as a matter of fact. First off, I need to identify which two triangles are similar. This red triangle is similar to the big one, right? Okay, so what are the corresponding side lengths? BN is given to me, BN, and that is corresponding to, BN is the first two letters, BR on the other one, is equal to, and also this one is given to me, right? BV to, BV is the first and third letter. First and third letter here is the BG. Do you have to do it that way? Not really. Okay, so once you get used to this, like you're just gonna write BN to this, and then this 8 to like 18. But I just want you to show that you can also see that like by using the letters there. BN is given to me as 12 over BR is given to me as 4x plus 7 is equal to BV is 8 and the entire BG is 18. And then a common mistake that people do here is they write like 8 to 10. You don't do it that way. 8 to 18 is the way to go. Ryan, don't panic. First, like study your algebra 1, I think. And then when I teach you this, like I will give you the entire worksheet and then I'll give you like notes. Today I go like a little bit more quickly because we only have like 1.5 hours. And there are stuff prior to this you learn, but I just picked a random topic here. I'm just like doing similarity today. And if you don't know proportions, how to solve proportions, just write it on YouTube and watch some videos. You'll get how to do that. Okay, and then let's solve this proportion like we did earlier. So reduce this by a 2, and then cross multiply. And do you have to reduce it? Not really. Okay, so 9 times 12, and then I'll multiply this one by 4. Okay, 4 times 4x plus 7 is equal to 9 times 12. And distribute. And before I distribute, I can actually divide both sides by 4 too if you like to. So that will give you a smaller answer. I'll just do that. Divide both sides by 4. See, that will reduce your number. 4x plus 7 is equal to 9 times 3, 27. So 4x is equal to take away 7 from both sides, 20. And then x will be equal to dividing both sides by 4 will give you a 5. Kavish got the right answer. Jayron also got the right answer. Awesome. Similar figures. Okay, so let's go down a little bit. Maybe like when did we start? 5:45, right? 5:45, 35 minutes. So remind me like after 10 minutes so we can just give it a little break. for 5 minutes, and then we will continue. I want you to do one more example before we move on. Which one looks the hardest? You pick it. AQQQ. You pick it.
6.
All right. The person who likes challenge chose it, right? Okay. What side corresponds? And this entire thing is 40, right? So this part has to be a not 40, but a 35. Okay. And then this bottom part is a 5 here. And then the bases are given to me as 2x plus 2 and 3x minus 7. Now here is my question to you. What side corresponds to 35?
ST.
ST, awesome. So 35 to 40 is the ratio, right? And then you'll write down, you'll make it equal to the base ratios and solve for it. And share your answers with me on the chat. No answers I got so far. Okay, Ellen shares an answer with me. Ellen, your answer is not correct because it's not so asking for X as a matter of fact. It's asking you for YZ. I think you got the correct X. Good job. See, the question asks for YZ as a matter of fact. Ellen, first correct answer. Crystal, good job. Victor, good job. You got the correct answers. Yifan got the correct answer too. Suhurit is also. Jaren, your answer is correct as well. All right, I got a lot of correct answers. So let's solve this problem. 35 is the side SZ, and SZ corresponds to ST in the other triangle. So that's 35 to 40. And if you look at YZ in the small triangle, YZ corresponds to first and third letter, RT. So these two sides lengths are congruent, corresponding to each other. So I'll write 2x plus 2 over 3x minus 7. Then Ryan, I need to once I write this one, I need to cross multiply these. And before I cross multiply, I'll just simplify this to 7 over 8 to deal with smaller numbers. Then I will cross multiply. 7 times 3x minus 7 is equal to 8 times 2x plus 2. And when I solve these, I need to distribute, right? The 7. I gotta multiply both terms by 7 here. 7 times 3x is 21x. 7 times 7 is 49, so it's a minus 49. 8 times 2x is 16x. 8 times 2 is 16. Take away 16x from both sides. You need to have variable only on one side. Okay, so that's a 5x minus 49 is equal to 16. Oh, no, I ran out of space. Okay, I'll just scroll down. Kavish, good job. That's the correct answer. Adding a 49 to both sides will give you 5x on this side, and we'll give you a 5 here, and then carry the 1 and 65. So dividing both sides by 5, we got x as the answer. At this point, before I choose my answer to be a 13, you know what I'm gonna do? I'm gonna read the last sentence. Okay, what's the question? Does the question ask me x? Not really, it asks me to find yz. So what I'm gonna do is, I'm just gonna look at the yz, that's 2x plus 2, because that's a common mistake. Usually 13 would be one of the answer choice if it's a multiple choice. So you gotta read your last sentence and see what you have found is the answer for the question, or is the question asking you something else. So that's a good habit all the time, always, just look at the question one more time before you finalize your answer. So it's asking me yz, and yz is given to me as 2x plus 2, which is 2 times 13 plus 2. That's a 28. Well, before me, Caitlin got it. Jason and James got the correct value for X. Of course, like read your last sentence and see if you're getting the right answer or not. All right, I'll just move on. See, like normally, like during the class, I will give you these worksheets in advance, so you will take notes with me during the regular geometry class. Because I didn't share any folder with you, I'm not able to share these with you for this class. But for the next one, you will have the worksheet in front of you, so you can take notes and solve the questions actually on the paper. And this page will be like your homework. So after I go over a topic, you will have a homework about that. Then we can just continue with the how to justify whenever you see triangles, how can you say that they are similar or not? How can you justify you claiming that it is similar? We are going to learn it right after the break. Okay, let's take a 5-minute break and we will continue after that. Okay, my timer is ready. See you after 5 minutes. All right, welcome back, everyone. So a good try of writing, you know. Yep, break is over. Let me just delete your annotations as well. Clear all of the drawings. Okay, that's good. All right, moving it down. So we will have some ways of justifying the similarity. In any triangles, if the two corresponding angles are congruent, then the triangles are similar. If you see any two angles, and if they have equal measure, then those two triangles are similar. So are these two triangles similar? Let's check it.
Yeah. No.
They are, right? Because the two of the same measures. Why is it not angle, angle, angle? Aren't all angles needs to be the same? Well, as a matter of fact, all angles are same here. The reason is the two angles are same, right? Because the third angle has to be like 180 minus these two angles. The third angles are also equal to each other. But if you know that the two angles are equal to each other, so 75 to 75 and 31 to 31, then you can claim that the triangles are similar by angle-angle similarity. Okay, so yes. So you'll write down your justification here. Yes, the triangle ABC is similar to triangle, and A is congruent to D. So D, triangle D, B is congruent to E. So D, E, F. By what? By angle-angle similarity, right? By angle-angle. And I'm just going to write angle-angle similarity here as a shortcut. I'm just going to use angle-angle similarity. So you got to justify like why you think that those are similar. I know that part is the boring part, but you got to do that. Now here, you will know like by the time that we will have similar triangles, actually you will know angle relations in this course. Okay, so if two angles are given to us as equal, see like that means like those two angles are congruent to each other. What other two angles do I know that they are congruent?
Vertical.
Vertical angles, right? Awesome. See, some people know their stuff. But I will also go over like those kind of relations, vertical angles, parallel, lines, crossed by a transversal, alternate interior, alternate exterior. We will learn all of those stuff about angles. But I needed to just like, I don't want to start from the first class here, but we will have those angle relations first before we have this class. So these two are vertical, so that's why I know that those two angles are same too. So angle V and angle X is congruent to angle Y and angle X correspondingly in these two triangles. So I can write the similarity statement here. Which two triangles are similar? Triangle, I can just name this any way that I like. Let's name it as VWX. It's going to be similar to the triangle. V is the same angle as Y. And then W is the same angle as Z because they are the unmarked angle here. And then the vertical angles X's are also equal to each other. So ZX. So these two triangles are by angle-angle similarity. So you need to like justify why you pick that they are similar. And if they're not similar, why aren't they similar? And the second one is side, side, side. And I know that the sides are not having equal lengths here, but they are supposed to be like proportional. If all corresponding sides are proportional, then the triangles are similar. If two pairs are proportional, but the last pair is not proportional, then they are not. All three corresponding sides ratios have to be equal to each other. Determine if the examples below are similar by side, side, side similarity. If yes, write the similarity statement. So let's look at the first one. What is the shortest side on this one?
3.
3.
And then shortest one is this one is 6. Is 3 over 6 equal to? I don't know yet. 4, the middle size over 8.
Yes.
Is it equal to the longest side? And then you can write the similarity like of the sides like this. You can go it's shorter to shortest, middle to middle, and then longest to longest side ratios, 5 to 10. Are they all equivalent?
Yes.
Yep, they are equal to all 1 over 2 indeed. So these two triangles are similar. I'm just going to write my similarity statement as PQR is similar to P is corresponding to S. So S and Q is the top angle, medium side. So TU. by side similarity. Are these two triangles similar? So what is the shortest side here? 30 and then 24. Is 30 over 24, is that equal to? Middle side is 32 and 25 here. 32 over 25. Is it equal to? You can already tell that it's not, right? 35
The
to
second one.
28. So are they equal to each other?
No.
No, they are not, right? This is actually, if you simplify this by a 6, you'll get 5 over 4. But you'll never get 5 over 4 here, even if you simplify with anything. Even the first two doesn't work. So they are not similar. Not similar. Okay. So no is my answer. And the last one is, so we have angle similarity. If angle means like the third angle is also the same if all angles are same. But if you can see that in two triangles, if the two angles are just same, even you don't know the third one, that's fine. You can just say that they are similar. If all sides are proportional, all corresponding sides, then they are similar. We call it side similarity. And then last one is a more complicated one, because sides needs to be proportional, angles must be the same, right? If two corresponding sides are proportional and the included means the angle in between, the included angles are congruent. So if I have like these two sides, 5 and 8, and then here, and then the other one I have like 4 and 3, see, like the included angles are the angles in between these two sides. If the two sides are proportional, they're not on this one, but the included angle is the angle in between those two given sides. Then the triangles are similar. Determine if the examples below are similar by side similarity. If yes, write the similarity statement. Okay, see, as you see, like two sides are given to me and an angle in between. So these are the K and N are included angles. And what does this mark mean? Like they draw a single mark here, single mark.
Congruent.
That means that they are congruent to each other. So if I draw this to J, okay, hold on, let me just draw it like that. If I do draw this, if I do the same mark, I really mean that J and K, M has the exact same measure. If I draw this double mark, and then if I put a double mark here, I really mean that P and L have the exact same measure. So you can mark the angles like that with the same, but 2 by 2, they have to match, but they shouldn't match with K and N. You have no evidence that L and P are congruent to K and N. So each time, like, try to get a like different mark for each angle. Okay, so now these side lengths are shorter one to shorter one around that angle has to be proportional. So I got to check if 8 over 6 is equal to 20 over 15. Are these proportional?
Yes.
So that's 4 over 3. That's also 4 over 3. See, these are proportional. So side similarity. So this one is the most complicated one, because like you first need to like determine which angles are given to you as equal, and then you got to look at the two sides next to each other. See, like if this side was not given to me, if 8 was here, then that wouldn't be side, because they have to follow the exact same order. A side has to be given to you, angle has to be given to you as equal next to it, and then another side has to be like proportional. Okay, so these two given side and angle in between, the sides has to be proportional and angles has to be the same. If this side was not there, but here, I would say that I cannot make any conclusion here. Okay, we will do a little bit of practice on those coming soon. Okay, so these are proportional, sides are proportional, and the angle between them are equal by side. I can state that JKL is similar to triangle largest angle M and P. And these ones are easy to write because they are given to me in the same orientation, in the same angular position. So they are given us like that. Okay, so here, which angle is the same for both of the triangles? I know that one angle is exactly the same, for sure. That is this one, right? Because angle A is common for both of them. So angle A, thank you, Victor, is the same for both of them. So just compare the sides around these two. One of them is 12 and having 15, and the other one is having 21 and 25. So write down short to short ratio, 12 to 21. Is it equal to 15 to 25? Are these equivalent to each other?
Mm.
Reducing this by 3, I'll get 4 over 7, but this one is 3 over 5, so they're not, right? So a big fat no. So all of the examples that they give, they were first like yes and then no. So you can go figure the pattern. However, when these are given to you in mixed form, see, then that's the real game begins there. See, we will just do some examples here. Now, these examples are only about angle-angle similarity. So are these two triangles similar by angle? Put yes or no, then we will write down the statement together. If it is yes, we will write a statement on these ones. Okay, Jaron said yes. Any other yeses here? Avery said yes. Trisha said Surit. Okay, so everybody's saying yes. There's no one claiming a no here. Caitlin said yes as well. See, one angle is given to me. However, in order to make a conclusion, so these two angles are same, but see, like that smaller of the acute angles is given to me. So find the other acute angle. 90 minus 39, it's a 51 here, right? So these two angles are matching, and then the 90 degrees are matching. So angle-angle similarity here. So by angle-angle similarity, I can conclude that triangle SYE is similar to triangle S is the 51 degrees, so I'll just start with the 51, W, and then Y is the 90, so C, and then the smallest angle E is the same as angle H. These two were indeed similar to each other. So let's give you another one. Are these two triangles similar or no? You have 5 seconds.
Yeah.
Yes, correct. Good job, Trisha.
Yeah.
Because these two angles are given to me as the same, right? And then these two angles are vertical, so I know that they're equal to each other as well. So if the two angles are same, then bam, that's a similar triangles. So you can quickly like guesstimate like this is the easiest one. I mean, if you know that two angles are same, you can just say that the triangles are similar already. But the other ones, you actually have to do calculations, like see side angle side and side. You actually need to check all those proportions and such. So they're not as fun as this one, I mean, as easy, but okay, so like determine this one by side. All the three sides are given. Are they all proportional, the side lengths?
No.
No.
No, because it's 4/5, right? Let's write the small to big ratio, 4/5. And then 7 is the medium side, 12, 7/12. It's already ruined, right? It's not, no. All right, so let's give you another one, this one. Are these similar to each other? And if they are similar, write down a similarity statement. I'm getting no's for this one. Nobody said yes so far. Did you actually check those? See, like
Yeah.
maybe you didn't like the number 43.2, right? Side. You gotta write the ratio of the smallest side to smallest side. 5/8.
Actually,
It's yes because of
it's yes. Yeah.
Is it? Okay,
Yeah.
12 to medium side, 43.2. And in almost all states, you can use a calculator for this class, as a matter of fact. Do you guys have calculators?
Yeah.
See, I have seen that Caitlin had like a TI-84, I think, yesterday. Do you have a TI-84, Caitlin?
I have it, but it's in my pencil pouch right now.
Okay. Yeah, you can use that calculator anytime for the geometry class. Okay, 15 to 54. And if you put that in a calculator, you will indeed see that they're all equal to each other. As a matter of fact, these two are, yes, they are similar. Now, guys, I want you to do this. I want you also write down the similarity statement. If I write the first part of that similarity statement, write one of the triangle name, like just follow any order here. Let's say I go with PAR. Is similar to. Can you guys please write down 3 letters for the next one? Not on the screen, but on the chat. What should be the correct order for the other triangle? Will it be like YRT, YTR, or TRY? What should be the order to write correctly to just complete that similarity statement?
YRT.
Everybody going with YRT. Are they correct? I see. And then Crystal says YTR. How about that?
RB at the end.
YTR or YRT?
YTR, right?
All right. P is the same as, P is opposite to the largest side, right? What is opposite to the largest side here? Y, right? See, Y has to be the first one. And then A is the opposite to the smallest side. T is the opposite, so YT. And then R has to be the last one. See, YTR was the correct answer here. YTR. So half of you got this correctly, actually. The other half was all wrong. So I guess you need one more practice on how to write down your similarity statement here. So we will have that, no worries about that. So, but I want to just go and do some side angle side questions before. And then I would like to give you these questions like, what justification do you use? Do you use angle, side, side? I want to give these questions like mixed to you, because when they're given mixed, then they're a little bit like harder. Okay, so let's like do this one, side, angle, side. Okay, here now, like, see, you need to know a little bit about angles for this question. And as a matter of fact, I have parallel sides given to me. Once you know the angle measures, like formed by parallel lines, you'll learn like this relation. So these two sides are parallel, right? Tell me a line that intersects both of these lines. What line is the line that intersects both of these lines? MQ or MP, they're both correct. Awesome, Jaren, Crystal. So this line just intersects them both, right? When a line intersects those red lines, parallel lines, they will form exact same angle here. We actually call these like corresponding angles. Because you didn't know that, I have to give you that part. So I know that those two angles are congruent to each other. Their measures are actually equal to each other. So now you're gonna check for side angle side, because I know that these two angles are same. Around it, I have like 54 and 36 on this one, and 33 and 22 on this one. So write down the corresponding sides ratio. Are they proportional? Are these two similar triangles? Work on that and give me your answer as a yes or no on the chat. Caitlin, show it on the chat, please. I know you love to write on the screen, but James said that it's a yes. And Ryan is saying yes too. Jaron, Trisha, Caitlin, Yiking all say yes. Okay, so 54 to 33, so you're gonna write down your proportions. 54 longer side to 33 on the other side, like on longer side on the smaller triangle, and the smaller one given to me around that included angle, right? We call this included angle, 36 over 22, and they're both equal to what? 18 over 11, right? They're both equal to 18 over 11. So because angles are same already given to me, and then the sides are proportional around it, so I'll just say that yes. And the orientation is the same, so it's easy to write the similarity here, CMP, RPQ. RPQ. You gotta be a little bit patient on this and then justify everything. All right, so let's do one more of this example. See, for this one, I know that these two angles are same because they are vertical angles. Vertical angles. If you have like intersecting pair of lines, they will form two pairs of angles, and these two are also congruent to each other, but they are not inside that triangle. So vertical angles. So because I'm given this now, you will try to justify if these are congruent, if these are similar or not. Okay, try to work on that and then share your answers on the chat. No one is writing on the screen. I am getting jealous. Okay. You can try, but you won't be able to.
No.
So is trying and failing on writing on the screen. One time, like I disabled the screen annotation. One person was still able to write on the screen. I don't know how he did that. He can hack this thing, I think. All right, so this is a hard question a little bit. Trisha says yes. James said yes, I think, but I don't know if it was the previous question. Jaren said yes. 100% yes. Jaren, see, like when I ask questions, you shouldn't say 100% yet. So do you write the proportion of these two sides and they were equal to each other, right?
Yeah, 5/8.
But was it a side angle side is the question. Yep. In order for it to be side,
it works.
it has to be a side length angle and then another side length next to that angle. All the two sides that are given to you has to be next to that angle. I know this 44, right? Around this angle. And do I know this side? What is this side? I have no idea, you know? Like in order, like for me to check this, first off, do I know two angles in these triangles? No, I cannot use angle here, right? Do I know all the three sides for both triangles? I cannot use side. The only thing that I can use is side angle side, but do I know enough information? Do I know enough information on this one? Do I know side angle side? And now these angles are same. I know this side, I don't know this side. And I know this side, but I don't know this side on the other one. So I cannot even use side angle side here. So I will say no. Actually, I just have no information. No info. Not enough. I don't have enough information to claim that these are like similar to each other. Okay. I don't have enough information. Not enough information.
So it has to be adjacent?
They have to be adjacent to that angle. Otherwise, and then like there is no side angle. Okay. There is no side angle. Not enough information. It has to be exactly a side, an angle next to it, and then another side next to that angle. It has to be an included angle, and then it has to be given the two sides. Otherwise, like if it is given to you in this orientation side angle, then there is no side angle similarity. And there are only strictly three of them. You gotta memorize them. Angle, very easy to memorize. Side, very easy to memorize. And then the only one that's like a little bit tricky is like side, angle, side, because the order of the information that is given to you has to be exactly in that order, side, angle, side. The angle has to be the included angle. These two sides has to be adjacent to that angle. All right. Next one, I want to do side angle side here. What angle is the same for both of the triangles? Tell me that first. Manual class at 7:15. Fine. L. Good job. Thank you. So this angle is the common angle. So the two sides next to L, adjacent to L, you got to write down the proportions. Are they equal to each other? So then tell me if they are side angle side proportional or not. But exactly, you need to check the work. I mean, you need to check the numbers if they work. Jaren says no. Jaren is about to say 100% no. 99.99%. Okay. Well, actually, you can say 100%, Jaren. When you know what you're talking about, like if you have enough experience, you can say like 100%. I like that actually, 100%. Right. Yiking says no. Caitlin says 100% no. Victor says no. Okay, since everybody is saying no, I'll just go ahead and like write down the proportion here and then solve it briefly. 27 is the shorter side here. Which one is the shorter side on the big triangle? I have like 36 here and then 39 here. 36 is obviously the smaller one. Sometimes they might be on different sides, okay? So if the smaller one is here for one and then bigger one is on the other side, and then if the sides are changing, it doesn't really matter. So go with 34. Small to small.
34.
What's the question?
34.
34.
Oh, 34. Thank you. Okay, so 27 to 34 is the smaller one. Is it equal to 30 to 39? All right, are these equal to each other, guys? No, right? I mean, if I cannot even simplify this to the same fraction. I can just write now here. All right. So now here are the good questions. Now when they're when they say, okay, so you're gonna check if these are like congruent by similar by side angle side, the question is easy. But if it is given to you in random order, can you tell which one of these angle side 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 or side angle side similarity you're gonna be able to use? Okay. So now like you will just tell me two things here on these ones. Determine whether the triangles are similar. If similar, state how by angle similarity, side side similarity, or side angle side similarity, and write a similarity statement. So if it's a yes, you'll tell me three things. Yes, angle similarity, and then you will just write down the similarity statement. You don't need to use the triangle sign there, but I will just give you a question. All right, for example, for this one, which one am I gonna use? Just tell me one thing here. Will I use angle to check this, side angle side, or side side side?
Side, side, side.
Side, side,
Side side side, perfect. Okay, if I am given this, will I use angle, side side, or side side side?
Side angle side.
Side angle side is correct because I'm given included angle and two sides around it. I have enough information here, I can do that. Okay, for this one, will I check side side angle side, or angle?
Angle, angle.
Angle is correct. Awesome. Now you know how to identify which one you're gonna be like using. Now let's actually use that information to come up with if these two are similar. Okay, just tell me if it's yes or no.
Yeah.
Yeah, Ryan, you may leave at early if you need to do have something else.
No,
No,
this is not.
no.
No, and Yuking is saying like yes.
It can't be.
Yeah, they are not, right? Because 61, well, I can't just say no at the moment. I need to come up with the third angle too on one of them. Maybe the other angle is the same as this one, but the third angle is what? 29 degrees, right? So if you add 61 and 90 and take it away from 180, or these two are complementary angles. So if their measures add up to 90, take away this from 90, you'll get 29. And apparently none of them is 34. So these two are not congruent to each other, similar to each other. Sorry. By angle. Okay, so let me randomly pick one more. I'll pick this one. Okay, number 8. Are these two similar to each other? Have a good day, Ryan.
They're similar.
Okay, they're similar. What did you do to check for similarity? Which angles are same? Which one did you use? Side
The
angle
angle-
side, the same. Side angle side of, all right. So 39 to what?
63.
63, the smaller one, right? Is equal to 52 to 84. And then once you check that, you got both of the same ratios, 13 through 13 over dividing it by 3 here, reducing it, you'll get 21. And then reducing this one by 4, you'll get also 13 over 21. They are indeed proportional to each other, the sides, and then the angle in between them are given to me as equal as vertical angles. So I'll just say that these two are similar by side similarity. However, I need to write down the similarity statement as well. So you can name one of the triangles however you like. RQS, let's say. Triangle RQS is similar to triangle, and R is the same as R in the other triangle. And Q is the side that's across to the smaller one of these. See, the U is the across to the smaller one of these. So I'll just go with like U next and then T. And there's only one way to write down the next triangle. Yiking, the class ends at 7:15, I think. All right, one last here on this page. Can you guys check this one?
15.
Okay, last one for this topic. Lucky number, right? Yep, side, 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 but are they similar? Everybody's like, okay, somebody with calculator, please check all these proportions, right? And I like to use mine like TI-84. If you didn't buy a calculator, I would suggest you to buy the TI, not TI-84, TI-Inspire as a matter of fact.
I
Yeah.
got a TI-84 Plus.
Yeah, but TI-Inspire is the better one, I think. If you don't already have it, like TI-84 is good, but TI-Inspire is the like updated version of that. And you can use this on SAT as well. See this one,
Yeah, it's similar.
this calculator, see?
Yep, it's similar too.
Yep, similar, right?
I tried to do it by hand.
Can you show it the calculator again?
It's just like, there is no point in doing this by hand, I think. So you can just write down 54 to what? What ratio did you use?
24.
24, the largest to largest, right? It's equal to 9 over 4.
Scale factor 9 over
What is the 49.5 to what?
22.
22. And that's also 9 over, wow, okay, so this gives me decimal, right? So I better go to the first one and make it a decimal. So you gotta put a point somewhere here. Kind of annoying. Okay, so that was all indeed 2.25. So I need to go ahead and check the smallest sides as well. 40.5 over the smallest one, 18. 2.25. Awesome. I did in head and estimated. Okay, Jaira. You are your own calculator. Okay, so let's move on. See, in the regular class, you would have a homework on this one. Triangle Proportionality Theorem. What is this? Okay, so that's like a weird name, right? So this thing will just kind of help you a little bit when the sides are given to you, or like when you have like parallel lines or something. All right. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional length. But this one has nothing to do with similarity, as a matter of fact. I mean, this is not the scale factor. So I can, if the two lines are parallel, the bases are parallel, if DE is parallel to, so DE is parallel to AC, then the ratio of BD to DA is equal to what? What do you think? Is equal to BE to
EC.
EC. But is it equal to DE over AC? No, because this is not the scale factor. This is not the similarity ratio. Similarity ratio actually tells you to write down the ratio of BD to BA, because those are the side lengths of the triangles. But what this theorem is telling you is, in other words, if you have like parallel line segments, okay, so if these lines are parallel, this one doesn't look like it's parallel. And then if you have like some lines intersecting these, they don't have to be like triangles, as a matter of fact. Okay, so if you have like two intersecting lines, they are intersected by parallel lines, the ratio of this x to y is going to be the same as the ratio of a to b here. Okay, so the ratio of x to y, so these line segments that are like cut by those parallel lines, those ratios are going to be equal to a to b ratio here. Does that make sense? And it's not equal to like this over that, of course. Okay, so this is only like about those line segments that are formed by parallel lines. This gives you a little bit of a shortcut in some problems. Converse of the triangle proportionality theorem. Converse means like you're going to learn what converse is in our second class, I think.
You switched them.
Converse means opposite of that. So opposite of that is also work. Okay, so if you know that the BD to, let me just write that down. How many of you knows converse already? Raise your hand.
do.
Awesome, Trisha. Okay, BD to DA. So the other way also works, but not always the converse is true if an original statement is true. They don't have the exact same truth value, but sometimes they do, sometimes they don't. Not necessarily one is related to the other. Okay, so EC, if this is given to you, then you can also conclude that the lines are parallel. DE is parallel to AC. All right, how does that help me? Okay, before, if I wanted to solve this question by using similar triangles, I needed to write 12 to 26, right? 12 over 26 is equal to 15 to the side length of the larger one that corresponds to that, 15 to x plus 15. However, now that you know those parallel lines must be forming like equivalent, like proportional, like side length on the sides, you can actually write 12 to 14 is equal to 15 to x. That only works for those side lengths, that line segments that are cut by those parallel lines. 15 to x, actually. So which one is easier, you think? Would you still go with the blue, like similar triangle ratios? Or
Now the red's easier.
red one is easier, right? But notice that you cannot use this when the bases are given, okay? So know the difference, because like sometimes I teach the similar triangles, and then when I teach this theorem, people are getting confused. Like when these are given to you, then people write 15 to x is equal to this over that, and now everything is ruined. No, they're not like proportional like that. This is not the scale factor, so the base ratios won't be equal to the line segments ratio here. All right, let's do some examples here. You can use either of the methods, okay? You can just stick with like similar triangles, write down the corresponding side ratios, but sometimes this comes handy. I don't want to have a like binomial here and multiply. I can just do this and then get my answer, the same exact answer, like in an easier way. Okay, I want you guys to apply either of the theorems you learned today and try to come up with the answer for 3. And you can use your calculator if you have one. Victor is the first one who got the correct answer. Awesome, Victor. Trisha, good job. Victor, which method did you use? Did you use the similar triangles or triangle proportionality theorem? So this name is triangle proportionality. Jayron, you got the wrong answer there. Suharit, good job. James, good job. Crystal, correct answer. If you use triangle proportionality theorem, and you can use it, okay, so the line segments that are formed by those parallel lines, x to 36 is going to be equal to this to 45, and then that part is 10, obviously, 10 to 45. Okay, that to this is equal to this to that. Because of triangle proportional, because of those parallel lines that are forming those line segments. And then I can simplify this as 2 over 9 and make the equal fractions by multiplying both sides by 4. X is equal to 2 times 4, 8. Or you can cross multiply. Yep, triangle proportional is kind of easier. However, can I solve this by using similarity? I want to solve it that way too, because I want you to see the difference. If you're getting confused with learning another one, like you don't need to know this triangle proportionality, as a matter of fact. It just like saves a little bit of time. X is this small side here, and the small side that corresponds to that is 36 plus x in the big triangle. Notice that you have a like binomial now. It's harder to solve this one. And now you need to know this side, it's still a 10. And write down the ratio of that to the entire side, which is a 55. If you want to use the scale factor and similar triangles, see, you can go with the small side to a side of a triangle. Never write x to 36 is equal to this to that or something. Like it's not the scale factor there, because 36 is not a side length of any triangle. But if you like to use triangle proportionality theorem, you can go with x over 36 like I did, and then 10 to 45. But if you want to use the yes.
Could you use the proportionality theorem here?
Yes, I already solved it that way. Were you here? Okay.
Yeah.
So x2, see, x2 36 is equal to 10 to 45. You can definitely do that. It's easier.
Oh, cool.
X will be
Okay.
80. And I'm just solving it the hard way now, actually using the similar triangles too, because I don't want you to forget this method as well. X plus 36, 10 to 55. Also, that is also gonna give you exact the same answer. But notice the hardship here for this blue one as compared to the red one. Red one is very easy to solve. This one, like you have X on both sides, and then you need to multiply a binomial by a constant. All right, one more. Use the triangle proportionality on 6. Jayron, it's all right. Calculation mistakes are fine. You need to solve like 100 questions, then you will reduce your calculation mistake. How many of you are out of Texas? Raise your hand. Or like use any hand gesture. That's fine. Out of Texas once. Fiona is out of Texas. Who else?
Like that lives out of Texas?
Yeah, who are out of Texas? Use like reactions, like you can raise your hand, clap your hand, whatever you have there. Alvin is out of Texas.
Wait, did I get it right or?
Yeah, okay, so let me just take the answer too. Yeah, you got it right. Trisha got the answer right. Jaren got it right. James got it right. Awesome. I'm looking for a few more answers. Okay, I'll use triangle proportionality theorem. This over that is going to be equal to this over this, right? By using triangle proportionality. Victor, good job. So 21 over 6 is equal to 3x plus 1 over x minus 1. And then I'll simplify this one. I want to deal with smaller numbers divided by 3. So 7 times x minus 1 is equal to 2 times 3x plus 1. Distribute 7x minus 7 is equal to 6x plus 2. And taking away 6x from both sides, x minus 7 is equal to 2. Adding 7 to both sides, you'll get x equals 9. Awesome, Crystal, good job. Crystal also got it before me. Would you like to do one more problem on this one or skip it?
Skip.
Caitlin is saying skip.
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 All right. And that also works, as I said. It doesn't necessarily be triangles, right? I can just use this theorem for any kind of parallel lines and or any kind of shape. Okay, so 45 to 18 here is going to be equal to 52
45 over 18 equals 52 over x, right?
Yep. And then you will do one now, okay? I want you to do, what if it looks like this? So then what is the value of x here on 15? Let's solve that one. What if it's not a triangle? Now that it's triangle proportionality theorem will still work. Parallel lines, okay? Parallel lines and proportional parts. So if there are parallel lines, any transversal is going to be cut by the same ratio here. It's going to have the same ratio of line segments. Okay, I got already correct answers here. Jayron, good job. Trisha, good job. Are there 2 Jayrons or just 1 Jayron? Okay, Jayron is like entering the answers twice, I guess. Okay. Suhurit, correct answer. Caitlin is bored. She's like, I'm not answering this question. James got the correct answer too. Okay, so what's your equation? 21 to 2x plus 2 is equal to 12 to x plus 3. And then you cross multiply this, 21x plus 63 is equal to 12 times 2x plus 2, 24x plus 24. Take away 21x from both sides, the 3x plus 24 is equal to 63. Take away 24 from both sides, 3x is equal to 39. Divide both sides by 3x is equal to 13 is your answer. All right. Does that make sense? I just solved it a little bit quick.
Yes.
Moving on. So then you would have a homework for this page on the regular class, but not now. Okay, parts of similar triangles. If two triangles are similar, then the following corresponding parts are also proportional to the corresponding sides. If you are given anything about these two triangles, like altitudes, they will have the same ratio because they are lengths, right? Angle bisectors, they will have the exact same proportion as well. Medians, they will have the exact same proportional. If the two triangles are similar, parts of the similar triangles are also similar to each other. So let's do one example here. These two triangles, KYC and BLH, are given to you as similar. So the corresponding sides are proportional to each other. The two medians are given to you, and one of the side lengths are given to you, the longest sides, I think. Can you solve for X here? Median is given to me. So medians are corresponding to each other. So 22x minus 5, right, is going to be equal to the longer side here is like the 2x minus 9, and the longer side is actually given to me 15. Also, if you're not sure if these are the side lengths that are proportional, you can check the letters too. YC is indeed corresponding to LH. Okay, so that has to be 2x minus 9 to 15. Oh no, did you get a quadratic here? Who knows how to solve quadratics? I do, okay. So I see some answers here already. Let me just check if they are correct. No correct answer so far. Oh, one correct answer, Victor. Victor is the victorious one. Got the correct answer the first time. James, Trisha, check your answers, please. All right, let's solve this one. So I'm gonna multiply x minus 5 by 2x minus 9. It's gonna be equal to 20 times 15. And the numbers are not easy either, right? Oh, could I have simplified this one maybe?
Yeah, you could, like, you can just multiply 20 times 15, you get 300. And you know, it like just factors out to those two. So you don't, so then 300 and then.
Yeah, okay, let me just simplify this before. I'll just like x times 2x is 2x squared, right? X times negative 9 is negative 9x. Negative 5 times 2x is negative 10x. And then negative 5 times negative 9 is 45 is equal to 300. And then 2x squared minus 19x plus 45, and take away 300 both sides, minus 255 is equal to 0. So how do you factorize this one? I think my answer key was kind of wrong on this one. 2x and x, right? What times what is 255? What are the two factors of 255 you used? (17) and 15.
I suggest maybe 5 and negative 17.
What and negative 17? 15 and negative 17?
Yeah.
Negative 17 and 15. I don't think, does that work? Okay, negative 34, right? And then a 15. Negative 34x plus 15x is indeed negative 19x. Okay, well that actually works. 2x plus 15 times x minus 17 is equal to 0. And from here I get that one positive answer, x equals 17, would be the choice, right? And then this one gives me a negative answer. I know that the side lengths cannot be negative. So I'm not gonna get that as like, and then if x is negative, then x minus 5 would definitely be negative. So in geometry, you only get the positive answers, so you don't get this answer.
Wait, when does your class end?
Ends at 7:15. Okay, the class already ended. All right, I will see you guys in the class time if you're taking the actual geometry. And then in that time, I'll just share these worksheets with you. So you'll have a lot of questions to answer yourself. And if you practice more, you will be more accurate and get the questions answers in a shorter time, which will be great for you. Have a good
Wait,
one.
Okay,
is
bye.
this like AP geometry, like same curriculum?
What do you mean by AP? Pre-AP, you mean?
Yeah, it's a high school course too, though.
Yeah, it's a high school course, geometry.
Oh, okay.
Yes. But it doesn't really matter. Like pre-AP, geometry, they all have the same content.
Yeah, yeah.
In middle school or high school, it doesn't matter.